15 from the Engine Mechanics Dynamics textbook. So the content I'm going to cover is the real-life example problem, the problem's formation, the key concepts that relate to chapter 15, and key equations. The backstory of this problem is that in order to test how fresh an orange is at home, you can simply do a drop test. The more fresher, more ripe an orange is, the more elastic it is, and the higher E value it will have. So by dropping an orange, recording its drop height and its bounce back up height, you can determine its E value. Although this is not an exact science that's used to determine how fresh or how ripe an orange is, most times when it comes to like more fresh oranges, online there's different sources, but there's an agreed kind of like overall range of the E value of 0.35 to 0.55 means that you can confidently say that it's a fresh and ripe orange. Here's a short video of the actual orange drop test, showing that when it's dropped, moment of impact, and when it bounces back up. So in this problem, we get a few givens and assumes. The mass of the orange with the mass of 0.1 kilograms, the drop height being 1 meter, the rebound height being 0.092 meters. Now obviously that we know that gravity is present with a value of 9.81 meters per second squared. We know that the ground is rigid and fixed, and we can assume that besides the gravity acting on it, that there is no air resistance or external additional forces or acting on the orange. And we can see that the orange itself can be considered as a particle. Here are some problem information showing the different stages of the orange drop test. So here are some drawn over photos of the orange in 3 different stages. Its initial stage, the second photo shows its moment of impact to the ground, and the third image shows when the orange bounces back up, showing its rebound height. In order to find this height, I use the in-app tool to compare how high it bounced up to the initial height of it being 1 meter. I took the rebound height of 0.092 meters. Here are some free body diagrams of the orange, showing 3 different stages of the orange as the forces act on it. The first one is showing its initial stage when just the weight, the gravity is working, affecting it. The second one shows the orange at the moment of impact, and the third image shows the orange when it bounces back up. Key concepts that were actually explored in this kind of problem is the concept of linear impulse and momentum, the impact of a particle on a fixed surface, and the coefficient of restitution. Key equations to use during this are the equation of coefficient restitution, drop height and impact velocity, as well as energy loss during impact. And here as an extra, I just show the results after the test. Using the data that I collected from my drop height, I got the E value of 0.3033. So although not perfect, it's still really good. And obviously to test it out, I ate the orange and it was still really good, showing that although it's a theoretical example and prediction, it's pretty accurate when it comes to real life implementation.